For this video, I'm going to talk about limiting reagents and how to solve chemistry problems that ask you to find the limiting reagent. To begin with, we need to understand that a limiting reagent is something that limits the amount of product that could be created. In contrast to that, an excess reagent is something that is going to be left over in the end. You'll have extras, you won't use it all up. So let's look at a sample problem. First of all, you have a high school chemistry student who decides to make water by burning hydrogen and oxygen. Now, your directions say to write the balanced equation first. So just looking at that one sentence, we can write the balanced equation. I know that hydrogen and oxygen are both diatomic, so it's H2 plus O2. And then they combine together to create water, which is H2O. I need to balance this equation though because it's not balanced. I'm seeing two hydrogens, two oxygens, but only one oxygen on my product side, which means I would need to put a 2 out front to make me have 2 hydrogens on my product side. But in doing that, it also makes me have 4 hydrogens. So going back over here, I would need to multiply my H2 by 2, making me have 4 hydrogens. Now I have 4 hydrogens on both sides, 2 oxygens, and then 2 oxygens on my product side as well. So there's our balanced equation. Now the question tells me that a student has 2 moles of oxygen and 2 moles of hydrogen. Looking at this balanced equation, I can figure out exactly how many moles I need. I would need 2 moles of hydrogen and 1 mole of oxygen. So given the information that I have, I can see that I would have some leftover oxygen if he had 2 moles of oxygen to start with. That would tell me that O2 is in excess. It's left over. And specifically, if he has 2 moles of oxygen, and our kind of formula here only says we need 1 mole of oxygen, there would be 1 mole of O2 left over, if the question asked me for that. That means that my other reactant, H2, is limiting. Now that was a pretty easy one and we could kind of do it in our head. The next sample problem is a little bit more complicated. We're going to have to use some math and some stoichiometry to figure out what the question is asking us. It says to determine the limiting reactant for the reaction between 8.4 moles of aluminum and 8.8 moles of oxygen gas. They create aluminum oxide. Step number 1 is always to write your balanced equation. So I have aluminum combining with oxygen, which oxygen is diatomic. Those combine to form aluminum oxide, AlO. But I'm not quite done. Aluminum and oxygen, when they combine together, have different charges. Aluminum is -3, and oxygen is, aluminum is +3, oxygen is -2. That means I would need 2 aluminums and 3 oxygens when they bond together. So there are my subscripts. Next thing I need to do is balance this equation. I'm seeing 2 oxygens and 3 oxygens to start with. So I'm going to make it so that I have 6 oxygens on both sides. In doing that, I just messed with the number of aluminums I have, so I need to put a 4 out front to make me have 4 aluminums on both sides. So there's my balanced equation. If we're thinking about what the question asks us to solve, it wants you to find the limiting reactant. So is the aluminum the limiting reactant, or is it the oxygen? And we know that we have 8.4 moles of aluminum, and we have 8.8 moles of oxygen. So which of those, you can almost think of it like ingredients, which of those ingredients causes us to have the least amount of product? So let's write that question down. That's the question that we're going to use to kind of frame how we solve this problem. Which reactant creates the least amount of product? And in the next question down here, I'm going to show you a different way of solving these problems. So a different question we could ask ourselves. So for this one, for part B, we're saying, does 8.4 moles of aluminum or does 8.8 moles of oxygen, which of those creates more Al2O3? So this means we're going to need to do 2 stoichiometry problems. I didn't give myself a ton of space. I'm going to do one problem right here and one kind of in the space over here. Let's start with our moles of aluminum. I have 8.4 moles of aluminum, and I want to convert that in such a way to find out how many moles of Al2O3 I would get. So I want moles of aluminum to cancel out, and I want to be left with moles of Al2O3. We're converting from moles to moles, which means I just need to look at my balanced equation to figure out what numbers to put into this conversion. Moles of aluminum has a 4, moles of Al2O3, my equation tells me 2. Plugging that into your calculator, you should get about 4.2 moles of Al2O3. So there's one possibility. We might make that much Al2O3. My other example, all right, over here, I'll squeeze it in. If I had started with the moles of oxygen, how much Al2O3 would that make? So let's convert it. I want moles of O2 to cancel, so I'll write it on the bottom. I want to be left over with moles of Al2O3, so I'll write it on the top. To fill these numbers in, I'm going from moles to moles, so I just look at my balanced equation. Moles of O2 has a 3, so I'll put that there. Al2O3 has a 2, I'll put that there. If you plug that into your calculator, you should get about 5.87 moles of Al2O3. So, looking at these two numbers here, I have 4.2 moles or 5.87 moles. Again, my question was, which reactant created the least amount? Because we're talking about the limiting reactant. Well, it has to be my 8.4 moles of aluminum, which created only 4.2 moles of Al2O3. So, if you have a highlighter, that might be nice. You could highlight this. I'm going to just kind of draw an arrow and write it in. This is limiting, which means that my oxygen is in excess. My oxygen would be left over. We wouldn't actually make 5.8 moles of Al2O3 because we wouldn't have enough aluminum for us to have done that. The aluminum would have run out as soon as we made 4.2 moles of Al2O3. So that means our aluminum is limiting, and this is how much we would make, and our O2 would be left over. O2 would be in excess. Let's do another one together. C says, determine the limiting reactant for the reaction of 12 moles of HCl and 7.5 moles of zinc. So it's the same type of problem, but we're going to solve it in a slightly different manner. So the question that we're going to ask ourselves is, how much of reactant A, we'll say hydrochloric acid, do we need to react with reactant B? So how much of reactant A is needed to react with reactant B? So it's going to get us the correct answer, just like this kind of process did up here, but the math it's a little bit faster actually. So, same thing as before, our first step is always to write our balanced equation. So HCl combines with zinc, and it doesn't tell you the products, but looking at this, you can figure out that this is a single replacement reaction. Hydrogen is positive, chlorine is negative, zinc is positive. That means these two positive, the cations are going to switch places. So the two positives will switch places, the zinc will bond to the negative chlorine. We will have zinc chloride. Zinc has a charge of +2, chlorine is -1. Means I would need ZnCl2 plus, I can't forget my hydrogen, I would have leftover hydrogen. And hydrogen is diatomic, so when hydrogen is given off, it likes to become H2 because it's diatomic. There's our equation, but I need to balance it. I'm seeing 2 chlorines and 2 hydrogens. This should be a pretty easy one to balance by just putting a 2 in front of my HCl. So this is a 1, 1, and a 1. There's my balanced equation. So I'm going to kind of give myself some space under here to do my math. Again, the question I'm kind of using to frame how I go about this is, Well, how much of one substance do we need to react with the other substance? Let's start with moles of HCl. So if I have 12 moles of HCl, how many moles of zinc would that take? So I want moles of HCl to cancel, I'll write it on the bottom. I want to change it to moles of zinc, I'll write it up top. Going between moles to moles, which means the numbers that I fill in are just going to be from my balanced equation. 2 moles of HCl for every 1 mole of zinc. I need to divide 12 by 2. That gives me 6.00 moles of zinc. So if I started with 12 moles of hydrochloric acid, I would need 6 moles of zinc for that reaction to take place. Looking back at the question, it tells me that I have 7.5 moles of zinc that's available. So is that enough? I need 6, I have 7.5. Yeah, that's plenty. I'm going to have some zinc that's left over. I'm actually going to have 1.5 moles of zinc that's left over. That tells me, so zinc is left over, which means it's an excess. My other product, which was the HCl is limiting. So there's kind of my final answer. Let's do another one together. D says determine the limiting reactant for the reaction between 12 grams of ethanol and 10 liters of oxygen gas. So I'm going to use this same process up here to figure out my answer. So I'm going to say which of those two reactants, the 12 grams of ethanol or the 10 liters of oxygen, which of those would create the most product? Before I do anything though, I need to write my balanced equation. So I have ethanol, which is let me write it over here, C2H5OH. And it doesn't tell me what it is, but it does tell me that oxygen is combined with it. So that's all I need to know, knowing that this is a type of, it's a gas basically, ethanol, combining with oxygen. So this is a combustion reaction, I should have said. Ethanol is it will burn, it will combust in the presence of oxygen. Our combustion reactions always form CO2 and H2O. Now we need to balance this. This is a tricky one to balance, so I'm going to go ahead and throw my numbers in. 1, 3, 2, 3 are what you should have gotten. So there's our balanced equation that I did super fast. So, our question that we're going to use to kind of frame how we solve this is, which reactant creates the most product? And it's up to you which product you want to use. I'm going to just say CO2. Let's do CO2. So we're going to say which reactant, either this or this, creates the most CO2. So I'm going to kind of draw a line down the middle, and I'm going to do 2 different stoichiometry calculations. First, I'm going to start with my ethanol. So I have 12 grams of ethanol. 12 grams of C2H5OH. And I'm going to convert that in such a way to find out how many moles of CO2 I would get. Moles of CO2. I'm going to do the exact same thing on the other side, but I'm going to start with 10 liters of oxygen, and I'm going to convert that to figure out how many moles of CO2 it would create. So 2 different stoichiometry problems. Let's fill in our numbers and our units. For this first example, starting with 12 grams of C2H5OH, I want grams of that to cancel, so I'll put grams on the bottom. 1 mole of C2H5OH has a mass, I just calculated it up, 46.08 grams. Pretty close to that. Now I want moles of C2H5OH to cancel, so I'll write it on the bottom. H5OH, and I'm converting it to moles of carbon dioxide. If I'm going from moles to moles, all I'll do is fill in the numbers for my balanced equation. This is going to be a 1, and this is a 2. So, there's my equation. If I do the math, I should get about 5 0.521 moles of CO2 would have been produced if I started with my ethanol. Let's do the same thing for oxygen. I have liters of oxygen on top, so I want liters to cancel out. I'm converting it to moles of oxygen. 1 mole of oxygen is 22.4 liters. 22.4 is your magic number for talking about liters and moles. Now I want moles of oxygen to cancel, so I'll write it on the bottom, and I want to change it to be moles of CO2. If I want to fill in my numbers, all I need to do converting between moles is look back at my balanced equation. So I'm going to have a 2 up here for my CO2, my oxygen will be a 3. Plugging that into your calculator, 0.298 moles of CO2. So looking at my two options, this number is smaller, so my 10 liters of oxygen would create a smaller amount of the product. Therefore, my answer is 10 liters of O2 is limiting.